Thank you for coming to the class here due to kind of a sudden snow and slippery road outside here. And so really rare I have this stop your video here, Jackson. And I probably will mute you. Can you mute Jackson? Hey. It's a mute button. Okay, so I cannot mute. Anyway, thank you for coming, and I do recommend you guys to download the NHCC app because sometimes I post. I don't know how many of you saw my post in NHCC apps, so then you can figure out that my class is moved to Zoom, or sometimes my class is canceled. Depends on so snow day like this. I do not want you guys to drive. So it's very. I want you guys to be safe. So please be safe. So one thing I want to point out here is that your test. So your test is upcoming Tuesday, which is next Tuesday, April the 2nd. It will cover chapter 5, 6, and 7. So when I see you guys back in Sam, I will be. Yep, thank you for stopping your video. Thank you so much. You know it. So I will ask. You will have a pre-test on Thursday. And then after that, you got a test on Tuesday. Again, pre-test and test are very similar. You do have a whole an hour and a half to do your test on Tuesday. Same thing as first test. You got the 4 open-ended questions and 10 multiple choice questions. And then you can allowed to have one front page of note. Again, one front page, not both pages. And I will check. And then you need StatCrunch to run your stuff here. Noah, I might need to. So please stop your video sharing. I do not need to share the videos because I will show my videos after that. So those are the stuff. It's very similar to test one that you took before. So it's not something new. And then if you have any questions, please stay back on Thursday. And I do have my office hours as usual on Monday and Wednesday after 4 o'clock, 4 to 6:30. And if you do need to meet with me some other times, please let me know. Any times will help, will work. Hopefully it's not have a time conflicts. So please, and then study your pre-test on Thursday, which I'll give to you. Okay. So homework-wise, let me see what kind of homeworks we have. Let me share my screen here so you guys can see. That is my screen. Homework-wise, you do have 2 homeworks due today, which will be 6.4 and 7.1. So 2 homework due on this today, and then only 1 homework due on next Tuesday, which is 7.2. So these are the 2 you do tonight. If you have any questions in your homework, please ask me. I think you guys know how to ask a question, right? Just select a questions from your homework. Let's say question 10, you need help. Just click on the help me to solve, get more help, and ask my instructor. And that's with type me an email, send it to me, and that's how you ask questions to my homework. And when I reply back to you, I'll try my best to reply back to you as soon as today or tomorrow. If it's the weekdays, weekends might take a bit longer time. Okay. So I think you guys know how to do it. So asking homeworks. So today's we will continue with 7.2. Where's 7.2? Right over here. So what is the difference between 7.1 and 7.2 is 7.1 is where I will ask all of these are using proportion. Okay. So I will highlight percentage, the word proportion. So this is a major, that's my proportion. There you go. That's a proportion. So major kind of like a stuff that you guys do. Oh, by the way, if you guys have any questions, you can raise your hand, you can put in the chat room, or you can unmute yourself. You guys know how to unmute yourself, right? And then talk to me. Okay. So because the whole 7.1 that we did here is all about proportion or percentage. Okay. And so what you notice about this proportion and percentage is if you look at your critical value, we use the Z. Okay. So in the critical value for this, we call the Z. What is Z? Z is your Z-score that you guys learned in chapter 6. Z in this case is called the standard normal distribution. Okay, so Z in this case is stand for standard normal distribution. Okay, what is standard normal distribution? It's a normal curve with a mean of 0 and a standard deviation of 1. So we just talk about that. Mean is 0, standard is 1. So all this value is a Z. So this is what we do when we do proportion. Okay. Because today we will learn a new distribution. So when you do talk about mean, we don't do the Z anymore. We will use the T. Okay. So I'll tell you what this is. This Z and T is called sampling distribution. Okay, so if a question always in a test or in your homework asking what is the sampling distribution of the population proportion, we always use Z, or in this case, Z-score, standard normal. And what is the sampling distribution when you do for the mean? Okay, so the sampling distribution for the mean in this case will be T. Okay, and some of you were asking what the heck is a T, and that's where you will learn today's. Okay, so right in 7.2 here. Okay, so this is where the T came in. Okay, so we are using T distribution, or sometimes they call it student T distribution. So I will explain to you what is all this distribution is. Okay, once we talk about the mean, just look at the questions. All the questions that we have here has the word mean on it. Okay, just want to point out to you. Mean on everything. Okay, and you won't see the word proportion here. Okay, so there's a difference in between proportion and mean. Because when I start in your test, you will notice that for the mean part here, you have the word mean. Okay. Now we start out with the word called the best point estimate. Okay. So if you kind of remember what is the best point estimate means, in chapter 7.1, we talk about the best point estimate. The best point estimate for the population proportion P is the sample proportion P hat. Okay. How do we figure out this best point estimate is when you figure out the confidence intervals. You always have this 48% plus minus 3%. So this 48% is what we call as your P hat, which is the sample proportion, and also what we call as the best point estimate. Best point estimate. And then the 3% at the back there is what we call we call this. What's that follow-ups? This is called the margin of error. And in proportion, how do you find margin of error? Is you take the upper minus the lower divided by 2. And how do you find the best point estimate or sample proportion? Few ways. You can take x over n, or you can take the upper minus lower divided by 2. So again, up to you which is given to us. If you know your x and n, you can figure it out. Okay. So this is what we did so far in proportion. Okay. So now we talk about the mean. So the mean in this case that we have in 7.2 is also have a best point estimate. But for the population mean, the best point estimate is going to be a sample mean X bar. So what do I talk about in this case is when you have the confidence interval for the mean. The confidence interval for the mean also looks something like this, but we don't use percentage or proportion. We use numbers. For example, is 72 plus minus 5. Let's say your confidence interval for your first test is 72 plus minus 5. This 72, like what we have here, is your X bar, which is called the sample mean, which is also called the best point estimate. Like what we did in here, okay? And the 5% of the plus 5, not percent, just the 5, okay, we don't have percentage. This is your margin of error. Okay, but finding the sample mean is not X over N. If you remember, how do you find mean is you add all your X over by N. Or if you know your upper and lower limit in your confidence interval, you end up divided by 2. And how do you find your margin of error? Same thing as we did it here. Upper minus lower divided by 2. So this is the, again, I'm showing you the fastest way. Do I record this friend of mine? Yep, it is recording. Sorry, I'm just want to double check. So we still have kind of the same thing. The only difference is proportion, we use either percentage or decimals. Mean, we will use numbers. Or more, another words also we can do here is proportion usually for categorical variables. And mean usually is for quantitative variables. So that's the reason why that these are the same concept, but different numbers in this case, okay? So that's what we do. So in order for us to find the confidence interval, we don't use the Z distribution. We will use the student T distribution. So this is a student. What is a student T distribution is? Student T distribution is what we call as a distribution that changes. And they changes depends on degree of freedom. Okay, I will explain to you what is degree of freedom. To find the degree of freedom is very easy. You take your sample size n and minus 1. Okay, this is the definitions of degree of freedom, which is a collections of how many number of sample values that can be changed after certain restriction can be imposed on all data values. And again, I want to point out to you guys is, do I come up definitions in my test? No. So when I look at the first test, when I look at some of your cheat sheet on the first page, one front page cheat sheet you bring, I see some of you put down definitions. So please do not put down definitions because I will never come up definitions in the test. But I will tell you what is the degree of freedom stands for. Okay. So let's say that I have 30 students. Okay. And I give a test today. And if 29 students wrote the name out, all 29 have your name on the test, except one doesn't write. Can I figure out this one person? Of 30 students. That is, yes, we can. Okay. The reason why is because once I put your grades in your grade book, and I found out that Adam forget to write his name, so I know that fellow is Adam. So that means that 29 is what we call as the degree of freedom. Short form is DF. And how do you figure out 29 is the degree of freedom here? Is you take your n, in this case 30, minus 1. And the 1 came from this one student that forgot to write your name. Okay. But if I change the scenario, I got 30 students, same, but now I got 28 of you guys wrote your name down. In other words, 2 of you doesn't write your name. Can I figure out these 2 students? Who is them? The answer is no. Then I have to ask either Adam or John, right? Because I got 2 names. I say, okay, Adam, John, which one's your test, right? So I had to figure out which one is which. Instead of me knowing it, I've asked. So that means that your degree of freedom in this case cannot be n minus 2. The reason why is because if I doesn't know 2 people, which is out of 30, I have to figure out who is the 2 that don't write. And then if you increase to 3, 4, 5, 6, same scenario. So that's why this is what we call as degree of freedom. So if we know 29 names, if you doesn't know one of them, we can still figure out. So this is called a restriction. So it means I know 29 people, and one of them is, so once we know this restriction is applied, then we can use the degree of freedom. So that is the meaning of the degree of freedom. Again, you do not need to know what is going on. Okay, just, again, if you're a stats major, you probably will be learning this from your professors. Okay. So what is the T distribution looks like? So I'm going to draw the picture here. Okay. So the T distribution actually looks like a bell shape. Okay. So what happens when you have a T distribution is you can have a smaller n. Okay. So let's say that if your degree of freedom is small, let's say 5. Okay. If your degree is 5, can someone tell me what is your n in this case? Don't forget the formula is n minus 1. So degree of freedom is 5, n is 6. Yeah. Yep. So that means that you only have 6 students, okay, in a class. Remember CLT? The central limit theorem says you need to have what? More than 30, right? But this T distribution or student T distribution actually says that if you have a smaller size, you can do a normal curve. But what happened is that your tail on the end here is thicker, and your peak is not as taller as a normal curve. Okay. Now, what happens if I increase my degree of freedom from 5 or n is 6 to a bit more bigger? So if your degree of freedom, the red one, is 15, in other words, your n is 16. So now if your sample size increased from 6 to 16, you notice that your curve will get a bit more like a Z, like a normal distribution, where the tail is getting a bit more thinner on the side here, and the peak is getting a bit more taller. Okay. And what happens if you keep on increasing your degree of freedom from 5 to 15 to 30? Okay. So when you increase it to 30, you get the green one. Okay. 30 means that your n is 31. And guess what? When n reach 31, CLT good here. So that means that this green one that we have is very similar to your Z. And again, what is Z stands for? Z stands for the Z-score or normal curve. Okay. So what is going on with this T distribution? So here are some little highlights we're going to do here. The shape of the T distribution is still symmetry and is still bell shape. But every shape that you draw here depends on your sample size. Okay, so it has a different shape based on different sample size. Moreover, the mean of this is still 0. Remember when we do the standard normal distribution? The mean is 0. Okay. But your standard deviation is not 1. Your standard deviation for any T distribution is greater than 1, more than 1. Okay. And the last features that we have here for a T distribution is as your sample size get larger, means 6 to 16 to 31 to 80 to 100 to 1,000, your T distribution will get very close to the standard normal distribution, which is the Z. Okay, so so when you look at the T tables, which I don't do tables in my class, when you look at the very end of the T table, you notice that it says large. That is your Z. Okay, I can show it to you here. So this is a table of the T if you for this case. And remember that last time this is called a Z-score. So we will call those as your T-score. Your mean in this case is 0. Your standard deviation is greater than 1. And you see the purple one is where the degree of freedom is 1, thicker on the tail side, a bit more shorter on the peak. And once you increase your degree of freedom, it gets what? Thinner. And if you look at the black one or gray one, that is your Z, standard normal. So what happens if you keep on increasing your degree of freedom from 1, 3, 8 to 20, this the graph will be going closer and closer to the black or gray line in this case, and the tail is getting thinner on the sides. So this is what is the T distribution is. This distribution is very, very important to us. The reason why is because you do not need to have more than 30. Remember, CLTs ask for more than 30. So that means that if I have only a classroom that only have 15 students, I know CLT will not work here. But however, the T distribution will work in this case. The history of this student T distribution actually comes from a person called Gossip T. His name is Gossip T. He is a CEO of the Guinness, the beer from Ireland. So he's actually one of the CEO that discovered this distribution back in the 19th century, 1800. And that time, he didn't want to use his name because people think that he might give out the recipe for making Guinness, the beer. So he just think, you know what, instead of using my name, I use a very anonymously name. So I just call this name as student T. He still uses his last name, the first last name, which is his name, last name is T something. So he's just use this until that when he retired, he's not the CEO of the Guinness company anymore. So what he did is he come out and he just tell everyone, guess what? I actually discovered this distribution. So I just use T because I don't want people know that, I'm giving out the recipes for the Guinness, it's a secret. So right till today, they keep this distribution anonymously, still use student T, not Gossip T. This distribution is used because during that time, Guinness cannot produce more than 30 batches or barrels of beer. They can only produce like 16 or 15 or 17 because, of demand. That time they're not that famous yet. So it's like, okay, I got 16, 17 barrels of beers. I cannot use the central limit theorem because it say more than 30. So he has to say, why don't I just create a new distribution? And now he got this distribution, and this distribution is used really throughout the whole world of statistics. And again, this distribution is a mutation from the standard normal distribution because it's still the same thing, but it's just changing the shape based on your n. Okay, so I will tell you that the old statistics stuff, mostly everything is based on the normal distribution, and we just keep on mutating it different way. So in other words, mostly they all will look like normal curve back in the 19th century statistics. And then when you go to the 20th and 21st century statistics, it's not going to be no longer normal. It's going to be a little bit different. So again, if you're a major in statistics, you will learn all these kind of distributions. So, but in this class, you only learn two, the normal distribution and the T distribution for the continuous case. And then for the discrete case, we learn the binomial. Okay, so make sure you guys, these are all continuous case in this case. All right, so we will use the T distribution here. So T distribution will have a different shape. So it depends on your degree of freedom. If you have a smaller degree of freedom, your tail is a bit thicker. But once you increase your degree of freedom, you find out that it is thinner. My drawing is really bad. So, and if your degree of freedom goes to really, really big, then you find out that your T will become Z. Your mean in this case is all going to be still 0, while the standard deviation is 1. Okay. Last time in the Z, we call this as your Z score. In T, this is called the T score. Okay. And also in chapter 6, you learn that this is called a probability, right? The shading of the area is probability. And guess what? The shading of the area is also called a probability. But you guys know that if you have the red one, the shading is more bigger or more than the purple one, because the purple one, the shading is very small because your degree of freedom is less. More, sorry, your degree of freedom is more, your tail is getting smaller, so your probability is getting changes. So that's why every single distribution that you draw on the T give us a different probability, although your T-score is the same T-score because the area is getting less and less. You can tell by looking at the graph. Okay, so that's the reason why that every time when you want to find the probability and if you want to find the T-score, you need to know your degree of freedom. And that formula for to find the degree of freedom is n minus 1. Okay, so it's very important to know this. So when you do your StatCrunch, they also will ask you for the degree of freedom. Now here comes some notations in this case. Anyone have any questions before I continue with notations here? All right. If you do, please unmute yourself or put in the chat room or raise your hand. What is mu stands for? Mu in this case stands for population mean. X bar, just do X bar first. X bar in this case is the sample mean, or sometimes we call this as your best point estimate for the population mean. Okay. The reason why we talk about this is because usually we do not know the population mean. But what we do in this case is we take the sample mean or the best point estimate and we predict the population. Okay, so if you ask me, some of you will ask me, David, what do you think about the second test? How well the students do your second test? That means you're asking for the population mean of the second test since you haven't took it yet, right? So then I will say, I will think the second test, the average is going to be around, let's say 70%. Then you look at me, how you get 70%? That is based on the sample mean from the previous classes I give. So let's say last semester I give this test, and that test, the mean for that test is 70. So I just tell you, yeah, your test for the next test too is going to be around 70 points. And then how do I know it's 70 points since I haven't taken the test yet, right? And I will say, well, I just look from the last semester test, okay, last semester class. So that's how we figure out, and that is called a best point estimate. Then we do what we call as S. S in this case is a sample standard deviation. Okay, so that is S stands for. N in this case is sample size. E in this case is called the margin of error. MOE, I just short form to it. And in order for you to find the margin of error, you take the upper minus lower divided by 2. Don't forget the formulas. Okay. And T alpha in this case is what we call as critical value. Okay. So again, what is critical value? We did this already in the P. So critical value is a value that's separating between the significantly low, significantly high, and no significant. So this value used to be a Z value, -2 and 2, if you remember, for 95%, is the critical value. But in this case, we don't use T. We use Z. We use T T-score here. So again, because the middle is 0, so the one on the left has to be a negative T-score, and the one on the right has to be a positive. Same thing with the Z that you guys did. Now, how do you find this T value or your critical value? You have to use your StatCrunch. So T alpha over 2, and the reason why there's alpha over 2 is because it has 2 tail or 2 side of 2 shading, left and right, left and high here. So that's why you will get the 2 alpha over 2. And in order for you to do that, you use stats calculator T. I'll show you where is it at. And degree of freedom in this case is n minus 1. And then you put the px greater than or equals to the first box to empty. The second box is alpha over 2. And again, what is alpha? Alpha depends on your confidence level. 90% will be 10% alpha, 95 will be 5, 99 will be 1%. And in order for you to find this kind of critical value, I have to give you n. So let's say I got 20. How many students I have today in my class? 24 students. So let's say my n is 24 here. So can we figure out what are the critical values for this case? Okay. So again, we'll jump to your StatCrunch to figure out your critical value. Where's my StatCrunch? StatCrunch. Okay, just like nope. So how do you find the StatCrunch in this case? For this, is you go to Stats and Calculator. So last time we used normal, this time we use T. So you guys asking me how many statistical distribution do we have? This is how many we have for, I say the first 3-4 statistics class you take: beta, binomial, Cauchy, chi-square. All these are different distribution that you will learn when you take in your stats for the future stats class. So far, we learned binomial, we learned normal, and now we will learn T. Then later on, when you take more, we got all this. Yes, you will learn, and this is not that it. We got more than that. Okay, so I will say, this is it. I say no, we got more than that. Okay, so we're gonna do T. So the first thing they ask you here is degree of freedom. So since I give you that the sample size in this class is 24, or 24 people attend my class today. So can someone tell me what is your degree of freedom in this case?
23.
23, yep. So make sure you know that is n minus 1. And so what we do in this case is we put the degree of freedom is 23 here. Okay. And in order for you to find the critical value, this is alpha over 2. You have to put it in the second box. And the symbol we use here is greater than. Now, if you forget to change the box to be greater than, you just only get this on the left side. So the difference between the greater than and the less than symbol is greater than means you try to find the t-score that is positive. But if you forget to change the greater than, you use a negative, it's fine. You just find the negative t-score, but you know that these t-score are actually the same, just the sign is different. Okay? So if you forget to change the symbol here, is fine. For the first question is the alpha is 10% or 0.10. So in other words, in order for you to find what is the critical value, you just divide this by 2 and put it in the second box. So you put this in the second box. So alpha divided by 2. So you will get this. So this is your, the first box is what we call as your critical value. And because the critical value comes in both negative and positive, so your critical value for this question is going to be negative 1.71 and positive 1.71. So don't forget you got two t values, okay, because of 2. And the next one is we change this into 5%. So for your alpha in this case, you just change your alpha to 5%. And the reason why we need to divide by 2 is because you got both sides, left and the low and the high. So that's why you need to divide this by 2. So you will get a t-score of negative 2 point something. 0.07, and don't forget the positive 2.07. And the last one is you change it into 1%, your alpha in this case. That means that you can tell by looking at the shading, it's getting smaller and smaller because our alpha is getting towards more left in this case. So it means your t-value is getting a bit more lesser, negative 2.81 and positive 2.81. So I just want you guys to take a look at this. So this is where we have 24 students attending today. Class leader is 23. So you look at the tail, okay? So what happens if I only got 6 students attend? Okay, let's take a look at your tail, what it looks like. Based on what I teach you and the t distribution, oh, this tail is actually a bit more thinner, should be get a bit more thicker. The reason why this is a bit thinner is because if you look at your t-score, this is 0, -5, and -10, right? What did we have last time? Is that 23? Okay. Look at that. Look at the value. This is no longer it's -2 and -4. So you find out that the other one, the reason why it's a bit thinner, but if I zoom it in between -4 and 4, you find out the tail is a little bit thicker, okay, when you have a smaller degree of freedom. Right? So this is something that that I point out early on in this, where your degree of freedom is, will be smaller, you have a thicker tail. Okay. Now here comes the requirements. So how many requirements do we have when you do this population mean to figure out? 2. Simple random sample and central limit theorem, which says the population is normally distributed or your sample size is more than 30. So this is your set CLT that we talk about. But then you say, David, you mentioned about this T distribution, about this Guinness guy. He don't have 30 barrels of beer. He only got like 15 or 16 barrels of beer. So now here comes what we call as the robust case. What is robust case means? A robust case means that your sample size is small in this case. Okay, so that means that we can still use a T distribution, as you know that, as long as you fulfill these 3 conditions for the robust case. Data is symmetrically closed, you have one mode and no outliers. So if you fulfill these 3 conditions based on a smaller sample size, then we will say if you fulfill all these 3, then CLT is considered meet, although our N is not more than 30. Okay, so we call this as robust case, and we'll be using this robust case a lot when we talk about mean. Okay, every time the mean pop up, the robust case will pop up again. Okay, so this is only to covering for those who have a smaller sample size. You can still use CLT as long as you fulfill these 3. Now, how do we check for symmetrical and no outliers? In order for us to check for symmetrical and outliers, you have to draw me the box plot, because a box plot will show us symmetrically and outliers. And how do you find one mode? You do your summary stats, okay, that you guys learned in chapter 3. Make sure that you got one mode in there. So in your StatCrunch, box plot is just graph box plot, and you draw your box plot. For the summary stats, you go stats, summary stats column, and then you remember the control A that you put in here in the statistics, and you compute, and you find out that the very last one is the mode. Okay, so make sure you find the mode in this case. Yes, I'll give some examples so you guys can see what is those mean. So only 2 requirements to find the mean. So now how do you find the confidence interval using StatCrunch? Again, I'm using StatCrunch here. I'm not using the wrong formulas. There are 2 ways for you to find confidence interval for the mean, for a population mean. Depends on if the question provide you the data or the question provide you with summary statistics. Now, what do you mean by summary data? Means the question gives you data files or call you to go to data files number 8, or you do your homework from your, you import your data file from your homework. Then we use this. So you go to tstat, one sample with data. But sometimes the question gives us the sample mean, the sample standard deviation, the sample size. Then the question didn't give you the whole data set. Then you will use with summary. Okay, so I showed to you what it looks like. So we got stats, tstats, one sample, either with data or with summary. And the reason why we use tstats in this case is because this is a T distribution or student T distribution. Now, when you go with data, they will ask you what column do you use, okay? And once you pick the correct column, you got 2 performance here. We are not doing hypothesis testing, we're finding the confidence interval. So make sure you select the confidence interval, put down the level. The rest of this you can ignore, and then you hit compute. So this is only happens if the question gives you data sets or you import data set into your here. But if the question gives you summary statistics, you will go with summary, which is the next one. And this time they want you to enter the numbers for the X bar, sample mean, S, sample saturation, and N, sample size. And you still need to hit on the confidence interval and change the level, depends on what level they provide, and hit compute, and you will get the results. So make sure you guys know the difference to use which one is which. Okay. And again, how many ways can you write your confidence interval? 3 ways. One way is putting your lower here and your upper here. But last time, if you remember, we don't use mu. In 7.1, we use P because P stands for population proportion. Okay. Another way is literally just use LU, the same way that you guys did in 7.1. The last way we do is this way, where the X bar in this case is called the best point estimate. And then the E is called the margin of error. Okay. So it's very similar to what you guys did in 7.1. Okay. But the only difference here is we don't use P, we will use mu. And then for the best point estimate, instead of P hat, we use the X bar. Okay. So, and how do we interpret the confidence interval? Interpretation of confidence interval is the same as the interpretation of the confidence for the proportion you learn. The only difference here is we don't use population proportion, we use population mean. So that's the only difference. So we are 95% confidence interval from the lower to the upper limits, again, your L and U, contain the true value of the population mean. Last time we used proportion. And what is the wrong way to do this? We don't use the word chance and we don't use the word sample. Okay. So it's very similar to what we did last time. We'll come back with this one if you have time. And again, how you find your margin of error. Upper minus lower divided by 2. And how do you find your X bar? Upper plus lower divided by 2. If the question gives you the both upper and lower limits, in this case, your L and U. Okay. We did this before. And the last question here is, if you want to be more accurate, to more accuracy, make sure you increase the sample size or you decrease the confidence level. Now, as you guys know that we never decrease the confidence level because you want the confidence level to be high, like 90, 95, 98. You do not want it to be decreasing to 80, 85, 80 to 70 because you are less confident. So for us, if you want to be more accurate in this case, please increase your N. Okay. So that means that if you have a smaller sample size, get a bigger sample size. So instead of I have 30 students, I will try my best to get like 100 students. If you cannot, then you have to think about this robust case that we talked about, right? So we'll talk about this. This is for question 1 that I come back. So we will go straight to question 2. So we'll come back here. I just come back here. Don't worry about that. So this is a question 2 that we will be doing. So this question 2 is, we will read the question here. So we got 36 Pepsi can. The weight of this is randomly selected. It has the mean of this and the standard deviation of that. Now, if you read this first sentence that we have, is this for sample or is this for population?
Population.
Someone say population, and then definitely someone say samples. So if you read this, guess what? It has this number. So usually, do population has a number in there? No. So this whole thing is actually what?
Sample.
It's a sample. For me, if you want to make it a population, then you cannot include this. So if you just say the weight of a Pepsi cans are randomly selected and the mean is that and such that. So if you have this without this number, then this sentence is a population. But if you have a N, which in this case, then it will be a sample. Okay. So in this case, it means that this will be your n. This mean is your x bar, sample mean. And this is your sample standard deviation S. And you are looking for a 99% level. Okay. So question A is asking for what is the best point estimate. Okay. So if you remember, to find what is the best point estimate, the best point estimate for a population mean is x bar. Okay. So in this case, what is the best point estimate in this case is your x bar. This is your best point estimate. And can you tell me by reading this question, what is your x bar in this case?
0.82410 pounds.
Yep, that is correct. So this is your best point estimate. Can you round this number?
No.
No. Please do not round. If you round this, you get everything wrong. Okay, so make sure you guys know this. So that is the best point estimate. So usually you do not need to really find it. I will show it to you also in your StatCrunch where is it will give it to you too. Okay. Next, critical value. So in order for us to find what is the critical value of T alpha over 2, so this is the same thing we just did over here, remember? So this is how you find your critical value. Make sure you know your n is a bit different here. So, so you have to use the degree of freedom of what? 35, because you got 36 people here. So 36 minus 1 is 35. And then in your T calculator, one that you guys use to find your critical value, make sure you use PX. If you don't use less than or equals, is fine. Make sure that the first one is blank. That's your answer. And then you do alpha over 2. Can someone tell me what is alpha in this case?
0.01.
Yep, we are doing 99%. So alpha in this case is 0.01. So you just need to figure out this using 0.01. Yep. So put it down in your StatCrunch for this case. Where's StatCrunch? So not this one. We were using T calculators. Calculators T. The degree of freedom is, I think it's 35, right? Let me see. Yep, 35. And then you can leave this blank. And then you will have 0.01 divided by 2. Okay. So this is your critical value in this case. Sorry, wrong Windows. So critical value in this case, it will be negative 2 point something and positive 2 point something. Negative 2.72 and positive 2.72. So this is your critical value, which you found over here. And this is your, I just bounced out your answer so you know what to do. Next, question C, you have to find the margin of error. But I will come back to this because in order for you to find the margin of error, you need to know your upper and your lower of the limit divided by 2. Okay. So in this case, we just figure out what first? The confidence interval. Okay. And what we are using 99% confidence interval. So how do we figure out this 99% confidence interval is, are we using data or summary? Based on the question given to us. Are we doing summary data or summary?
Summary.
This will be a summary. And the reason why this is a summary is because they give you all the summary statistics. So in your StatCrunch, go to stats, tstat, one sample with summary. Okay. Otherwise, data will use that. And you will have to enter your mean. Your sample mean in this case is this number, 0.8 something. I'm going to make this smaller so I can go side by side here. 0.82410. Standard deviation is this one, 0.00570. And sample size is 36. And the confidence level we are looking for is a 99%. So this is the 99% confidence level. And hit compute. And this is the result you will get. So this sample mean is the same sample mean as what is given here. We also call this sample mean as best point estimate. Standard error, again, this standard error is used if you want to find margin of error the difficult way, where you take the standard error, multiply with the critical value. Okay, so if you want to find the margin of error, if you want to use the old way or the long way, is you take the standard error times your critical value. So if you take this number 0.00095 multiply with this 2.72, you will get yourself your margin of error. Okay, so standard error times that. But usually we do not use this formula. We use the upper minus, so divide 2 is quicker. Okay, but no matter which one you do pick, you get the same. Okay, and then DF stands for degree of freedom, but the most important case is your lower and upper limit. So based on your calculate, sorry, there's a lot of windows going on in my computer screen here. If you want to figure out what is the 99% confidence interval, your answer in this case is 0.822, around 3 decimal place, and 0.827. And don't forget, this one has units. And since you can tell that they're all in pounds, so the unit in this case is in pounds. Okay. So proportion have no units, but mean has units. Okay. Now we can backtrack to see. Again, you can find your margin of error using upper minus lower. So you just need to subtract these two and divide it by 2. So we can erase this now. So so that will give us an upper, which is 0.827 minus 0.822. Subtract this and divide by 2. So you can take out a calculator. Okay, this is easy. Parentheses 0.827 minus 0.822, and then divide this by 2. So your margin of error in this case will be 0.0025. Okay. Now, again, if you do not want to use this method, which is the method I always tell you guys to use, upper minus lower, you can also use the standard error, which is given us by this, times with the critical value that you found in B. So if you take 0.0095, this number, times with 2.72, you should get kind of the same, 0.0025, or in this case, 26. Potato, 2526. Okay. So you will get kind of the same, 0.0026. So this is also another way to find the margin of error. So in the test, I don't care which way you want to use, upper minus lower or the standard error times with the critical value. No matter which way you do, you will get it correct. Okay. And the last question, E, is to what? Write a statement to interpret. So how do we do interpretation in this case? Put E here. No room. We are 99% confident. Remember the interpretation that we use. That the interval from the lower 0.822 pounds to 0.827 pounds, capture the true value of the population mean. Now we're going to figure out what we're talking about. It's in the question, population mean weight of Pepsi can, which is given to us in the question here. So we're talking about the mean of the Pepsi can. Great. So what is this confidence interval that you found here? It means that if you go and buy a Pepsi can, I don't care where you buy it from here, in Asia, in Europe, wherever it is, make sure it's the same 12 ounce. I believe it's a 12 ounce can, and you go weight it. That weight should be what? Between these two numbers. How confident we are? We are 99% confident. That means that I will tell you that mostly all your Pepsi cans, if you go buy regular, not the sugar-free or whatever, the regular Pepsi can, the 12 ounce, and you weigh it, it's going to be around 0.822 to 0.827 pounds. For sure. Okay, 99% sure. You guys know what I'm trying to do here, class? That means that if you go buy 100 cans of Pepsi and weight them, 99 of them will in between this weight. Only one can falls either below or above that weight. Only one out of the whole 100 cans. So that is the power of statistics. We can predict the population because when you go buy, it means population. We doesn't know where you buy it. But we can predict the population. Okay, so we use this a lot to again predict who is winning coming elections. Predict, if you want to create a head size to build a helmet or to like your seat for your airplane, we can design that so that the design is going to be around this range. So when you design it, it's going to be around here so that when you build it, you will fulfill almost 99% or 95% of people. Okay, only the 5% might be complaining, too big, too small. Okay, so make sure you understand this. So a very important case that you study here. Okay, question 3, we do the same thing, but this time you have to refer to data set number 1. Body data, you have to construct a 95% for the population mean for the female. And then you also have to design it for the male. So you got two confidence interval you have to do. And once you finish designing it, you have to compare the results. Okay. So what do we do in this case is since we know it's given us the data. So in your StatCrunch, you will figure out using the data. But first, pull out the sample data set number 1. Okay. So go to the data set number 1 here. Okay, body data. So we are talking about the pulse rate. Okay, this is what we're mentioning. So this is the pulse rate. Pulse is the pulse rate. So if you doesn't know which one of these is pulse rate in your test, raise your hand. I will tell you, oh, it's this one. Okay, but when you look at the pulse, it is a mixture of male and female, where it's written down here that one is male. So that means that this is female, this is male, this is female. But this question wants to separate between male and female. Female and male, sorry. So what we do is we just do it. I'll show you how you do separation. How do we separate between 0 and 1 here, the gender. So you go to stats, you go to T-stats, one sample with data, because we know data in this case. Okay. And we are doing pulse rate in this case. Now, this is where you separate is the word group by. So every time when you have the word group by means that you want to separate this into groups by gender. And again, we are using a confidence interval and we are looking for a 95% confidence interval. So we will select compute. So when you select compute, your StatCrunch will automatically split 2 confidence interval. As you can tell that 1 equals to M means the 1 is for the male one. 0 is for the female one. So you find out that the first one is for the female, and the first one, the 0 is for the female and 1 is for male. So let me repeat how we do this. So you go to the pulse, because we're doing pulse rate. Make sure you group by the gender. Don't put anything else, because this is where you separate your group. And the confidence level is 95% based on the question, and then you compute it, and that's where you get this. Okay. So using for female, so I'm going to figure out what is the female is, purple. So 95% female in this case, I just put F for female, is given us by these two lower and upper limits. 70, around 72 and 76.0809. And again, the units in this case is beats per minute. I don't know, you remember in your first test, if you lazy, if you scared I take points off, you just circle the units and then label that's your unit, right? So that's your unit in this case. And I also mentioned to you that starting test number 2, I'm not very care much about unit. So if you forget to give me units, I won't deduct points, because the first test is the one that I will look for the units. Second test, if you do it, good. If you forget to do it, fine. Okay. For the male, you look at the second confidence interval. In this case, is 67.77 to 71.13 beats per minute. So again, class, I am teaching you the fastest way to find confidence interval. You have no clue. If you want to do this by hand or doing by tables or by formulas, you're gonna take at least 2 hours to do this question, because we have almost how many students? We got almost 300 people here. Okay, so happy to. I was saying that you'd be crying. Okay, so what we need to do next is we have to compare the results. So how do we compare these results? It's very easy. Is to figure out, are they overlapping? Overlapping means that are the two confidence interval touch or go along to each other. If you say yes, these two confidence interval overlap, then the female and the male is the same pulse rate. If you say no, then either the female is more than male or the female is less than male, depends on where the position of the confidence is. So let's draw this on a number line. So let's say you got 60 here, 70 here, and 80 here. So let's figure out where's the females at. So female is between 72 to 76. This is the female confidence interval. That means that if I go and pick a female in any class or any place, I test what is the pulse rate of that female. Her pulse rate is going to be between this. Okay? Normal pulse rate, resting, not doing the test. And for the male, the pulse rate in this case, oops, sorry, wrong, 67.7, so it's somewhere around here. And 71.39, somewhere here, 4. So this is the male case. So my question to you is, do these two confidence interval overlap?
No.
Okay, so we don't overlap. So since we do not know overlapping case in this case, so now you can tell me, is that female is more than male or female is less than?
Female is more than male.
So in this case, the female pulse rate is more than male pulse rate. So this is usually how we compare the results, is to figure out this case. Okay, so if they overlap, automatically female and male are together. I don't care how little and how much they overlap. As long as they overlap, then they are equal. But if they're not overlapping like this case, then you see which one is more. Okay, so for this case, female's pulse rate is higher than the male's pulse rate. So this is how you compare your results. Anyone have any questions with number 3? Hey, Last one, question 4. So listed below are 15 randomly selected LA commute times. You need to construct a 90% confidence interval to figure out what is the population mean commute times in LA. And then the question is the confidence interval is a good estimate? So what we do here is you have to enter this data into StatCrunch. So usually you enter them in var1. So go to a StatCrunch, okay, and pick any variables you want, and then you enter this. Now in your homework, you just export, import into your StatCrunch, so you do not need to enter them. But in your in your task, you don't have the export, import features, so you have to enter this data correctly. We'll check the data if I enter them correct. 25, 45, 55, 40, 25, 8, 55, 5, 30, 15. So these are the commute times in LA in minutes. Okay. In order for us to find what is a 90% confidence interval, is this data or sum?
Data.
This will be data because the question provides us data set. So what you do is that T-stats, one sample with data. Okay. Some students ask Z-stats. Will we ever use Z-stats in our class? Will we ever use Z-stats? The answer is never. So please do not use the Z-stat because you see, Z-stat also had the same thing, right? One sample with data. So make sure you use T-stats. What's the difference between Z and T? Z-stat is for the normal curve. Remember the normal curve that we did here? This is the Z-stat. This is T, but we don't use Z here. We use the proportion Z. So that's why when you look at this on the stat case, you got a proportion stat. So proportion stat is for proportion. The Z and T is used for mean, but we don't use Z, we use the student T distribution. That's why we use the T-stats. So in another words class, please do not use the Z-stat in this class. If you pick the Z-stat, I will guarantee you everything is wrong. Okay. So we will use the confidence interval. We use the 95. I think the question wants us to figure out 90. Oh, 90. Sorry, it's not 95. 90. So we're going to change it to 90. And hit compute. So the 90% confidence interval that is given to us here is these two numbers, 14.66 till 30.41. And again, if you want to know what units is this, the units are in minutes. So usually some students ask me, David, is a unit always in parentheses? I will say yes, usually they are in parentheses like this. Okay, so this is how you construct a 90% confidence interval. Now here is the question. Is the confidence interval a good estimate? Now, in order for us to figure out if this confidence is a good estimate, you have to check the requirements. So remember, a good estimate is talking us to check the requirements here. And what kind of requirements do we have to check? So if you kind of bounce back up to the requirement check, there are two requirements, SRS and CLT. And if you got a smaller sample size, robust case that you have to check. So we're going to check this. So we're going to check first is SRS. Again, you can use SRS for shortcut in the test. Do we have SRS? Yes, we do. The word random is like this here. 2, do we have CLT? Now, CLT says population is normally distributed and sample size is more than 30. Do you have the word normally distributed in this question? I don't see it. And how many sample size do we have? If you count this, you only have 15. We don't have this. But don't forget, if your CLT does not match, you have the robust case here. Okay. So we are checking the robust case. So since we have a smaller size, so we will check the robust case. And in the robust case, we will check symmetrical, one mode, and no outliers. Pardon my really bad handwriting. So we're gonna check the symmetrical and no outliers by graphing the box plot. So go to your box plot, var1. Make sure you draw the box horizontally. If you want to draw it vertically, it's fine. Compute. So we can tell by looking at this box plot, it has no outliers, because outliers usually have little stars on the end. Now my question is symmetrical. Now don't forget, it is close to symmetrical. Now, what is the meaning of the word symmetrical? Symmetrical means this is your median. The one right in the middle is median. The one median here is a midpoint, a center point. Is this point going to the minimum and this point going to the maximum? Are they kind of the same length? So from this middle point, median, go to the mean, and midpoint go to the max. Are they kind of the same length? If you say yes, then it's considered symmetrical. So symmetrical or not?
Yes.
Yes. Again, we don't talk about the line. Oh, David, there's no line here. Don't worry about that. Symmetrical, just cut this into half. Is that literally? In this case, it is symmetrical. Okay. So this is how we figure out symmetrical using a box plot. Just cut the median in half, and if they two are exactly kind of. Okay. Okay, now we're going to check for one mode. So how do we check for one mode? Is go to stat, summary stats, and column, var1 and Control A. Remember the Control A you guys learned before, and hit compute. It's always at the end. So how many modes do we have? One mode, and that mode is 5. So in this case, do we fulfill the robust case in this case?
Yes.
We do. So if you fulfill robust case, that means the CLT is good. Although this is although the CLT says that. So it means that the requirement here is what? They met. So now the question is this a good estimation? Since you met the requirement, means the answer will be
yes.
Yes, in this case. Okay, so that means this is a good interval to use. Okay, so this is how we figure out if you have a robust case here. Okay, now before I jump back to number 1, I just want to point out that this homework is due on next Tuesday, the 2nd, which is also your second test. So you will have a Thursday, a pre-test. And if you guys have any questions, please come and talk to me. Okay, so this is important. So please study this, very important. And you still have the one front page of notes, so make sure you start transferring those. Okay, so what we did here is mean, and everything we did is all based on T distribution. So now we go back to number 1. Now this question 1, we're gonna use this, but this is too much to remember. Okay, I will short form this on here so you guys can see it. So in order for you to do the question 1, the question 1 is asking us, which critical value should you use? Z alpha over 2, T alpha over 2, or neither? Now you notice that when we did so far here, everything we did here for the critical value is based on T alpha over 2 because we are using student T, right? So how do we know, are we using T or Z? This is what we do. First, check CLT condition. If you have CLT condition is met, okay, then you ask yourself if sigma is known, sorry, bad handwriting, or sigma is unknown. Not known. Okay. Now, if sigma is known, we will be using Z alpha over 2. Okay. And sigma is not known, we're using T alpha over 2. Now, what happens if the central limit theorem does not match? Then you will do neither. Okay. So why is this? This is because if you remember what we did in the StatCrunch, you got stat, right? We got these two. Remember, I say we never use Z-stat. Z-stat is only used when sigma is known. And what is sigma stands for? Sorry for my bad handwriting here. Both of these are sigma. Oh my God. So what is sigma stands for? Sigma in this case means the population standard deviation. So if your population standard deviation is known or given to us, we will use the Z-stat. But the population sigma is not given to us, we use the T-stat. So we find out that majority of the stuff that we did here, the standard deviation that we give it to you here is always S, not sigma. That's why we're using T. Okay, and same thing happens to this. The question did not provide us sigma, so that means this is going to be T. And same thing here. The question did not provide us sigma. We use T-stats. So that's the reason why that every single one of these examples we do is all based on T-stats, or in this case, T-distribution. But sometimes sigma is given to us, then we use the Z. Okay? So I don't know how many of you look carefully on the title. It says that to find the mean where sigma is not known. So that means sigma is not given to us. We always use the T here. Okay, T-stat. Okay, and we never use Z-stat in this case. The only time you use Z-stat is somewhere on this question 1. Okay, and this kind of questions, I would love to ask in MCQ. Okay. Can someone remember the CLT theorem? Population is normally distributed, and sample size has to be what? All, not n. All sample size is more than 30, right? So if you're fulfilling this, you have to go on. So first, we check question A. We want to check this CLT mean. So central limit, the sample size in this case is small. No, good. However, the population is what? Normally distributed. So in this case, CLT met. Because if you have one of these met, it's good. And then you ask yourself, do the sigma is known or not known? So now sigma is not known. So for question A, so central limit theorem is work. Sigma is not known. Are we using Z or T alpha over 2?
T alpha over 2.
We'll do T alpha over 2. So how do you find T alpha over 2? In your T calculator, you have to figure out degree of freedom. Don't forget, degree of freedom is based on n minus 1. Since we got 9, so 9 minus 1 is 8. So Px less than or equals to something. And usually this is where you put your alpha over 2. Can someone tell me what is the alpha for question 1? So based on the confidence level, yep, alpha is what?
0.05.
0.05. Yeah, so what we do is we just replace the alpha with 0.05. So jump to your T calculator in your StatCrunch, stat calculator T. Degree of freedom is 8. And then this is 0.05 over 2. So your critical value T alpha over 2 is negative 2.31 or positive 2.3. And don't forget, you have 2, right? What
Wait,
is
I have
that?
a question.
Mm-hmm.
How did you get the 0.05? Like, where did
It
you?
based on confidence level.
Oh, okay. Thank
So
you.
95 is 5%. And sorry, my handwriting is really bad with this. So this is the pointer. That means that for this whole entire question, your alpha is going to be 0.05. And then you plug it over here. This is your answer. Sorry for the bad handwriting. I told you, teaching Zoom, you have to tolerate my bad handwriting. Now we try question B. So question B, N is not more than 30, so no good. And what happens to the population? Is it normally distributed? It says it is skewed. So do the CLT fulfill or not?
No.
No. So if your CLT does not fulfill, then what is your answer? Neither. And what is the meaning when I say neither? That means it's not Z, not T. That means you have to use another chapter, or in this case, we call it the non-parametric stats, which you will not learn in my class. So that's the reason why that we use neither in this case. Okay. How about C? Sample size is small, also no good. However, your population is what? Normally distributed. Did CLT good? Yes or no? CLT is a good, but now you look at the sigma. So once you say yes, so you look at the sigma. Since this question sees sigma is known, so since sigma is known, we will use the Z alpha over 2. Now the Z alpha over 2, we don't use the T calculator. We use the normal calculator. Forget, this stands for normal. So we don't use this calculator. We use the normal calculator. And we do the same thing. Now, don't forget, a Z stands for mean is 0, standard is 1, and you still use the alpha over 2. So it's kind of the same as what we did here, but you don't need degree of freedom. And you hit compute. So this Z alpha over 2 will become plus minus 1.96. Okay, so we will use normal calculator for this. And for this one, we will use the T calculator. Now let's take a look at the last one, D. Sample size is huge. Now I don't care what is this. Once you say sample size is huge, the central limit theorem applies. It applies. And now we will look at sigma is known or not. So since central limit theorem is applied and sigma is not known, so in this case, we'll be using T alpha over 2. Again, T alpha over 2 is the T calculator. But now your degree of freedom, in this case, is N minus 1. So it will be 75 minus 1 is 74. And we still use back exactly the same P. So this is always used no matter if you're using T or a normal calculator. So we're going to use a T calculator for this case because sigma is known, not known, sorry. Oh, calculator T. And the degree of freedom here is given us by 74. and reduce 0.05 over 2. Same thing, and this is the answer. So for this case, your answer is plus minus 1.99. So this is how we do this question number 1. And as I mentioned, this question is definitely coming out in your multiple choice as in your second test. Now, this is 4 questions already. I cannot count 4 questions in your test 2. You only get 1 of this. Okay. So what is this called? You're finding critical value for this case. And that's how we figure it out. Right. So that's it for today. We finish up this 9.2. I know I've burned up 5 minutes for you guys. So I will put this everything I wrote down in detail out and also send an email. I also send you the link to a YouTube video that is recording this right now. So you will see everything here. So please rewatch, redo when you do your homework, you know, as when you study for your test. Please watch this again. So hopefully Thursday we'll be back into the classroom. I don't think so that this is hopefully the last tier of the snow. So otherwise, if there is something on back to the Zoom, please check your email or check something else, but usually it's back to the classroom. You will have a pre-test number 2 when you come back on Tuesday. And then same thing, you guys spend 30 to 35 minutes during the pre-test too, and then we'll do an hour after that to go over all the pre-test question. Again, your pre-test question only consists of open-ended type, not the MCQ multiple choice type. So this kind of questions that we just did just on number 1, you will see it. So you kind of go through your works, and if you see putting a number next to it, there's an MCQ pop up. That means those questions will be coming up in the multiple choice question. Okay. Anyone have any questions for me before we stop this Zoom meeting here? And if you do, please stay back. Otherwise, you may leave. I'm going to stop recording here.